Hi, this is King of Review. Here we have to find the product of all possible integer values of x in this log inequality. Well, to start, since we have x inside of a log, we have to remember that any number inside of a log has to be greater than 0. Right away, that tells us that x squared minus x minus 2 must be greater than 0. To solve this inequality, the left side factors into x minus 2 and x plus 1, since negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1, the coefficient of x. If this product has to be positive, greater than 0, then one of two things must be the case. Either x minus 2 is positive and x plus 1 is also positive, or x minus 2 is negative and x plus 1 is also negative, so that they multiply to make a positive number. Solving these inequalities, we get x is greater than 2 and x is greater than negative 1, and x is less than 2 and x is less than negative 1. On the left side, if x is greater than 2, x is certainly also greater than negative 1, so all we need here is x is greater than 2. Or, on the right side, if x is less than negative 1, it's certainly also less than 2. So we just need x is less than negative 1. Now that we know those restrictions on x, let's return to the original problem. We have a log base 10 on the left side, a log base 10 on the right side. We can raise 10 to the power of both sides, because there's a property of logs that says if you have some number b, you raise it to the log base b of x. The b and the log base b cancel out, and you're just left with x. Since our two logs are base 10, raising 10 to the power of both sides cancels out the logs, and we are left with x squared minus x minus 2 is less than or equal to 4. Let's solve this the same way we solved the inequality on the left. We'd like 0 on the right side, so we can subtract 4 on both sides, leaving us with x squared minus x minus 6 is less than or equal to 0. This polynomial on the left side factors, just like the first polynomial did, into x minus 3 times x plus 2, since negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. We can solve this similarly to how we solved our first equation, but now we need the numbers to be less than or equal to 0, which means either the first term is less than or equal to 0 and the second factor is greater than or equal to 0, or the first term is greater than or equal to 0 and the second term is less than or equal to 0, so that they multiply to give us a negative number, or 0. Solving the left side, we get x is less than or equal to 3 and x is greater than or equal to negative 2. Rewriting that as a compound inequality, we see negative 2 is less than or equal to x, which is less than or equal to 3. On the right side, we get x is greater than or equal to 3, and x is less than or equal to negative 2, but a number cannot be bigger than 3 and less than negative 2 at the same time. So the solution on the right is impossible, and we just have negative 2 is less than x, less than or equal to x, which is less than or equal to 3. Let's combine this together with the two possibilities we know from our first inequality, and we will see where our solutions for x can be. We know it could be less than negative 1, and if that's the case, the lowest it can be is negative 2. So putting this on a number line, it can be negative 2 since this is less than or equal, but it can't be equal to negative 1, it just has to be less than negative 1. Or, alternatively, x could be greater than 2, but we know the highest it can be is 3, and it can be equal to 3. So x must be in one of these two intervals. We know we're looking for integer values of x. The only integer values included in these two intervals are negative 2 and 3. So if we want the product, that will be negative 2 times 3, or negative 6. So there's our answer. Thanks for watching.